All right, we're finally back. That was a new one. COMP308, it's winter 2017. We're at Centennial, and it's Emerging Technologies. We're week 4, part 2 of our broadcast. We've tried to put up the biggest problem that we had with this whole thing was, and why Azure was failing, and now it's working. See, the routing is working, right? The reason why it was failing was because we were trying to get our font awesome and all web fonts working. However, we had an incomplete web.config file. So if you look at my GitHub repository, you'll see that I've made several commits, 10 commits now. And most of the commits are all around fixing my web config file. You can see like web config. And finally, I got to a compatible web config file, which looks like all this. This is all the stuff that I put in there just to make sure it looks like that's the things that blocked it, because I got to kind of tell the IIS server that I'm running server.js. I'm running a node site. And so I need a proper web config file for whatever reason this time around to make that work. To be safe, I recommend installing that web config file, the new one. So what I will do is up on Slack, and if I go to our folder here in our developer, I'll say correct web.config file Azure, and we'll point to it, and we'll put in the link for that, which I will drag and drop from my folders, because obviously that wouldn't work. So here it is, and upload. So now you have it. Please get it from the developer channel of our Slack. That's why this Slack's awesome for this kind of stuff. Please grab it from there and include it in your projects. It'll just guarantee that it's going to work and we're not going to have issues, right? It'll be part of my template going forward. Okay, so that's number one. So now that our projects work, this is where I wanted to end off last time. I have my routing. I have my template pages. You're good to go for assignment 1. Again, for tonight, what I'm looking for is please put up your pages. I don't need all of the pages to be filled in for tonight. All I need is your home page to have something that looks like it's a portfolio set that's about you. And if you start that off and you get it done by midnight tonight, you get 2% bonus for your, for you. And then you'll be well on your way to start your assignment. So next week, when it's time to hand it in on the Friday, you'll be fine. Okay? Any questions around that? Great. Let's move on to MongoDB. We're running late. We have about an hour and a half. And I got about 3 hours of content. Let's see if I can do this. Right? I'm going back to talk about a little bit of theory now, and it's in my, up on eCentennial, I put up a PowerPoint presentation, Intro to Mongo, right? I pulled this other stuff together because I wanted you to have everything you need. But what I want to do now is I want to talk about Mongo and what it is. So way back, everyone was using something called relational databases. They still use relational databases today. For the most part, I think that's what's happening, especially in the biggest sites. Again, the biggest, I would say, market share for back-end servers is still PHP. 8 out of 10 sites is PHP, right? We're still working at 15% approximately, so that's the other 15% would be mostly ASP.NET, and other services would be around 5%, with Node being that 2% of the 5. The rest is like, Java EE, and Python on the back end, those kind of other web services that are very minimal. But 80%, approximately 80% or 78 or something like that is PHP, actually. So because of that, they had, most of the sites, including ASP.NET with Microsoft services, that 15%, 95%, I would say, or in that range, 90 to 95% of our market share, all uses relational databases. And you've learned about that by now. Right, you know about relational databases. You probably use a SQL Server. If you did ASP.NET with me in COMP309 or in other courses, you've done relational databases. But Mongo is a non-relational database. And usually they use something called object relational mappers, like the Entity Framework. Entity Framework is a great example of an object relational mapper that wraps everything around a SQL Server, so you don't have to use structured query language by itself. Example would be like select, star from, I don't know, table students, whatever it's going to be, right? You don't have to do that. you can use another statement, almost like you can wrap it up with code to make it a lot easier. And that's what the entity framework does. We don't have that here in this situation, and there's a reason for it. So they had this issue where, SQL Server and any kind of SQL-based or relational database had an issue when it came to scaling. And part of that is the larger it became, the bigger and bigger the database became, it became very challenging from a retrieval of information perspective, right? And it does it pretty quick, but sometimes what happens is there might be a situation where I don't need a massive relational database to store my information. And sometimes it's not the right approach, more of a horizontal type of approach as opposed to vertical. And so there's some thought around moving away from a relational database to almost like a document storage solution, right? So imagine that you're storing documents as opposed to records in a database. That's totally different. So again, document-oriented database came on the rise, and they used something on the back end at the time. This is all around the same time. They used something called either JSON or XML type structure to house their data, right? As opposed to the way relational databases work, where they store it in tables and inside the database itself. That's a totally different structure, right? And here's an example of a database that includes some posts. I'm just going to make this a little smaller for you guys to see it. So you have this, the idea of posts. You have the post table and you have the comments table if you're going to create a blog, right? So both the posts will hold all the posts, and then there'll be a reference to the comments will be relating to a specific post. So you'd have all the comments in one comments table and all the posts in the post table, and you would have a foreign key inside the comments table that points to the post table. So here you have two tables, right? Because of this whole and the idea of this relation. Now this can be very cumbersome because that means that for every post you could have multiple comments, right? And what happens is it becomes a little bit tedious in terms of writing this. You have to write the foreign key, the relationship, the procedures, all that kind of stuff that's in the back end. So again, at least two tables. But Mongo, what it does, and document-oriented databases do it like this, right? You use JSON-like format, right? We're going to talk about this in a second, what this looks like. But here's a way you could write it within a document database, where you have JSON-like format, the title of your blog post, and comments. And I want you to think about this as this object here is the document that's inside of a collection, right? So when we talk about MongoDB, we don't talk about records or tables. We talk about collections, tables, and documents, records. So record is no longer, we don't use that word when it comes to Mongo. We use documents. And that's kind of the same idea. So again, the idea here is efficiency, right? And that's what it's all about. I'm not going to read, this is all excerpts from the book. I'm going to kind of go through this a little bit more. And I don't know why I put model and changes on two separate paths of typing error. But as we go forward, you can see that it's less efficient to do something small like this with a relational database. Now, the great thing about document-based databases, and that's why they're called NoSQL, is because there is no SQL statements to use. And there's something that we call schemaless, right? Whereas you need some kind of model. So think about a model like in the object relational mapper example that we use with entity framework. Remember, we had a model class, and the model class would kind of describe each field inside of the database, right? And the table. But in this case, you don't need that. And so it's by default, MongoDB and other NoSQL databases are schemaless, right? We can define a schema, and we often do, because it makes sense for us to structure our database, right? But it doesn't require it, and it actually is very flexible, flattened, framework, a hierarchy compared to the hierarchy of having multiple tables. Now, like I said earlier, you cannot just say that MongoDB is the best option there is, or nor can you say that a relational database is the best, right? You've got to choose the right solution for your problem, right? And this may not be the solution for your problem, although some big companies have seen it as such, like eBay is a good example. They've gone with MongoDB. They've moved away from relational databases. So again, your application is the thing that modifies everything. The schema is held in the application, in this particular case, not in the database. So the application is the thing that's taking care of everything. It's doing all the sorting and searching, and all the logic is on the application. The database, we're using the database just as a data store, right? In this new reality. So again, this document-oriented database approach, originally, we came out with different ones. There was all kinds. There's CouchDB. There's a bunch of other ones. And then they came up with MongoDB, and MongoDB had the best features at the time, right? And now is the most popular. I still have to point you back to other document databases like Microsoft's version, DocumentDB. That's their version. And they also have other ones, such as Firebase, which we're going to handle later on in this course. We can't do it now, right? But they're document databases as opposed to relational databases, right? And there's another reason why they wanted to do that is because you use JavaScript notation across all lines now. So first you had JavaScript on the front end, then you got JavaScript on the back end with Node, and then we put JavaScript in the database. It looks very JavaScript-like. And as long as you understand JavaScript objects, you understand how the structure of a database, right? Which is awesome. That means you know one language and it kind of covers it all. And that's why the whole mean stack uses Mongo primarily, or a Node document database, NoSQL database somewhere inside that solution stack. So what is Mongo? Back in 2007, they were looking for some kind of hosting service, or service as a platform as a service. And that's what they were trying to do, these two guys, Dwight Merriman and Elliot Horowitz, right? And they found that they wanted to create this document-based database solution. They called it Mongo because it's based on this idea of a humongous database. And right now, the great thing about this, and I found this really interesting, was that Mongo has over 10,000 commits as of the writing of the book. That's huge. So that's something it's a community-supported open source project, which is awesome. That means you can actually go there and make your own Mongo database if you really want to, or a Mongo version. Or contribute to the community by recommending pull requests and all that kind of stuff. But really what it does is it uses NoSQL storage, and it has a lot of really cool features. They use something which was very JSON-like, all right? So again, the structure, like I showed you earlier, was very, very JSON-like. And they use this idea of horizontal scaling. So it's scalable, but it's flat, all right? So it doesn't require multiple relations from one collection to the other. You can actually put everything into one collection, and the collection itself can have multiple nested documents. So one document inside of another document inside of another one, which is a different approach than doing one table and here's another table. You don't have to do that. You can put like one table inside of another table inside of another table, equivalent, right? And it's just nested documents. An example of, we're going to see some examples in a second. Again, really cool things. Again, eBay and the New York Times really were the first two that kind of use them. And there's other people that use MongoDB as a backend now. Okay. Features. Let's talk about some stuff. Again, they use this JSON-like storage, like I said, named BSON, which stands for binary JSON. That's what it really stands for. So BSON, right? It looks JSON-like, but it's not JSON. All right. And the idea is you have key value pairs inside the structure, right? They also have, which is really interesting, a unique ID. So underscore ID is, and within every document, you'll have an underscore ID, right? That's your primary key. And the primary key is auto-generated. That's what happens. So I'm explaining how it works, right? And it uses a lot of times things like 4 bytes from, the seconds since the Unix epoch, right? Whenever it came from, right? Some kind of random number, right? Because, or actually it's an accumulated number. 3 bytes from your machine, whatever your machine identifier is, or the server. 2 bytes from your process, as an example. 3 bytes from your counter, starting with a random value. And they come up with this hash that's unique. So all of your documents that are inside of the collection, again, I want you to hear the terms. Collection, in your mind, you should think table, right? Documents, in mind, you should think records, because you're trying to, kind of adapt from relational database structure to a non-relational database structure, right? Here's an example of what it looks like. So here's a document, a single document, where you have a key, ID, and a value with your object ID, which is the ID of this particular document, right? The document has 2 properties. Remember, we don't call them fields anymore, properties, because just like they would as an object, right? One of the properties is a title with a value of first blog post, and another property is comments. That is an array of comments, right? Which is not, it's not a relating to another table, another table of comments. It's got its own comments. So each document can have a different array of other information, which is actually, we found, more efficient, right? In some ways. Although it can be hard to manage. The more relations you have, the more nested documents or arrays, it can be very challenging. And so if you have a lot of relations and you're going to build something that requires a lot of relations, go back to a relational database, because that might be the best solution. Okay. So it's not just one, there's no, one size fits all here. So again, they have this idea for limited query capabilities, but the idea with Mongo is kind of decided that they can do multiple queries. So here's an example of a default SQL statement like this: select star from posts, where there's a filter where title is like Mongo, and in a similar way you can do something like this: DB posts. Sorry, it's hard to see this. DB post find, right? So I use DB, so MongoDB. My post collection, so my post collection, right? So this is this part, right? Find, and in quotations, in curly braces, a title that matches a regular expression, Mongo, right? Mongo. So that's the exact same thing, pretty much, right? And we're going to talk more about this kind of stuff. Correct. It's beautiful, right? So searching becomes way better because you're using regular expressions, right? As opposed to the search functionality of a relational database. They use a mechanism called indexing to make sure that you have performance. And one of the other things that it has is, I'm not going to go too much about performance. Here's an example of, again, if you have a set of comments, right? So so my comments count as 12, and I want to sort so I can see any blog post that has comments that are greater than 12 or greater than 10, right? So more than 10 comments. How do I filter that? Well, you can do that by using this. So find posts. So find documents in the post collection that have a comment count that is greater than, that's what $GT stands for, greater than 10. Done. It'll return all of them. So that's the way we put it. Now we're going to check this out. And to do this, to test this out, let's use Mongo, because I can talk Mongo all day, but you won't understand it until we actually do it. So here, I'm going to pull up a terminal window. I'm going to get out of my FTP, which is completely unsuccessful. And I'm going to clear, right? So I'm using this is my lesson folder, right? And I'm going to pull up another terminal window. So here's another window, right? Here's my other terminal window right here. My other terminal window is going to be the MongoDB server. So I'm going to say sudo MongoD. If you're on a PC, you just put MongoD, press enter. So it launches the server, right? And you should be running on 27017. I'm going to just minimize this, so it's going to keep up the server window over here. Now I can go to any terminal, and I can go Mongo by itself. And now if you notice, it's going to say this: connected to test. Test is the default database. Okay, test is always default database. Now, you're going to be, I'll be honest with you, when we build up our Mongo database, okay, the one thing that you have to understand is this. This is a very useful window to go into because you can actually see what the documents in the collections are, right? I have several. So if I go, here's the thing, db.show, right? Okay, if I go, if I want to use a certain thing, for example, let's say I want to use a certain database, doesn't exist, the example games, right? Notice that it says switch to database games. Do I have a games database? Hell no, but what it does for you, creates it. As soon as I use it, it's created, done. Now I want to say DB, and then the collection would be my games, right? So my game, the game collection in games, right? I want to insert a game, right? So I can use the insert keyword, and I can insert certain values, key value pairs I'm looking at. I'm doing this all in one line so you guys can see this. I'm inserting a value. My key would be the name of the game, right? My value would be the value of the game, right? Which would be, let's say, Fallout 4. We're talking video games, right? Someone's having a problem, right? Must be my thing. So this is the one value, right? So notice that I've put in my insert here. Here, question for you: shouldn't I have something else in here, like another curly brace? Because I'm making a statement like this, right? So at the end of my statement, I'm inserting this, just putting it out there. Right? Do I need this? I'm kind of doing it. Well, the answer is probably not, right? Probably can do this. I mean, we're just guessing. Let's insert. We use the insert keyword for this, right? And if I just insert the name of the game, right? No rating or anything like that. And if I want to, if I think about a rating, some other kind of things, like for example, rating, and then, we want to, we want to put the rating of a value of out of 5. Let's say we'll make it 4.5 out of 5, right? And then we close off the brackets and press enter. If we did everything correctly, it'll say this: right result, inserted 1. Okay, so I can use, now I never had a game collection, right? I have a games database and a game collection, and I have my game collection has one document, if we did this correctly, with a name of Fallout 4 and a rating of 4.5. Let's see how I can find this. I can do db.game.find, and if I use this as a method, if I press enter, it'll show me this thing here. I know it's kind of hard to see because of the screen, but the idea here is that I've created a database. The name is games. When I just said use, it just created it automatically for me, right? It didn't exist before, right? And then db.game.insert. This is my insert criteria, right? Here's my right result. And game.find, right, returned the result. It actually was able to read from the database. So here's my insert, my create. Here's my read, right? I want to update. Let's do the update. So I want to change the name of I want to change my rating, right, from 4.5, right? I want to change it to 5, okay? Well, when we're updating the document, I have to do the same thing. So db.game, right, .update. Now this is 2 parts. I need the document, how I'm searching for the document, where here's the first part, where the name, right, is equal to Fallout 4, comma, and then, oops, comma. That's the search criteria. The first part of update is search, and the second part of update is what I'm going to insert, right? So I'm going to kind of talk about what it is, where my rating, we'll say this now, you'll see it's a funny result, is equal to 5. Right? Now, what do you think, before I enter it, what do you think it's going to do? Any questions? Any? So there's 2 parts of this request, and we're going to go over it. Actually, the document itself, the PowerPoint, actually tells you how to do all this stuff. But let me take a look here. So what do you think it's going to do? Fallout 4 and then rating 5. Do you think it's going to update from rating 4.5 to 5? Is that what you think it's going to do? Let's see. If I press enter, it says right result 1. It says matched 1, upserted 0, right? That's different. And modified 1. So I modified 1, matched 1, because the matching part is this part. The first part is the request, right? The next part is what I'm changing. This is what I'm updating. Now let's see db find. So we'll say we'll kind of go up to db find, and now I get this. Oh man, what happened to my name? It's gone. So here's a lesson for you guys, and this is why I told you. You think that it's going to update only one action, but actually what it's done is it's eliminated my name altogether. And the reason why it eliminated my name is I didn't mention it. It's like I need to feed it a whole object again. I need to give it the name. I need to give it the value. So whenever you do your update in code, that's why I'm showing you this, right? You need to create a new object, which means you need a schema, right? Here's my name. I need my document has a name. It has a rating right now. Maybe a cost, something else, whatever you want, right? Let me go back, put that back. So I want to update this again, right? So and again, if I clear, it doesn't show that it doesn't clear anything. Let's quit the database for a second. So if I go quit, right, quit, and clear the screen so you can see it, and let's do this again. So Mongo. Notice that I'm going to use games. Now if I go, here's the thing. If I go db.show, right, or is it? I think it's dbs.show. So show databases. Show, huh? Oh, who knows? going to show me all the databases. If I do it properly, I'm just not using the right command.
db.show.
Is it? I want to kind of quit so I can. db.show with no brackets, right?
Yeah.
No. Where's my database? Where's my games? Right? Use games. Switch to db games, right? And now I want a I want to find everything. db.find. Right? Oh, that doesn't work. How about db.game, the game collection, .find. I find one. So
db.get collection names.
that's db. So that's a different thing. I want to show all my databases. How do I do that? Right, that's the thing. And by the way, for you to find all these commands, we don't have to guess. There's a great website for this. If you go to mongodb.org, and if you look at the documentation, so if I look at docs on the left here, and then if I want to do my Mongo server, right, and there should be commands, right? So, you know, I want to kind of do different commands. It talks about storage and sharding and everything else. So here's my reference, right? My reference document for operators and searching and sorting. So how do I show? So the other way to do it, of course, is to say show DBS. Is that what it is? Show DBS in Mongo. So what's the command for that? Right, show collections. So if I go to show DBS here, did it the wrong way, show DBS. There's all the DBs that I have, lots of them. And then if I show, I'm using collections. I'm using CLS. If I'm using collections, CLS clears. I would do show, right, collections, because I can do this because I'm in the I'm in the games database. So show DBS shows all my databases. CLS clears the screen. Show collections, because I've already used the use games. It shows my game. That's my only collection I have. Show DBS. Now let me look at something else. Let me look at some other thing like Lucy, as an example. Lucy was one of my students one time. So I'm going to use Lucy. Watch. You don't have Lucy, but I'm going to do it. Clear. Show collections. So this is something that another database that I used to have. Fruit and fruits. Let's go db.fruit.find, and that shows me one fruit, a name, which is brown bananas, and a color that's brown. All right. Now, how do I insert the fruit? Do I have to do name and color? What do you think? Name and color is something that they've been entered as in the fruit collection. Do I need to use name and color? What do you think?
To replace.
No, not to replace. Just to add another one. I want to insert another document. Do I need to use name and color? No, right? So there's no schema. It's schemaless, right? So I can do something like this: db.fruit.insert, right, as an example, and then I insert what I want. I don't care about I'm not inserting the ID. I could specify an ID if I want, but I don't have to. It's auto-generated for me. And I could do something like this. I could say my name, is Apple, right? And my color, Canadian color. My color is red apples, and my type, as an example, is the red apple. It's the red apple, right? Red apple. That's the type, right? And then I can have that. I can have as many or as few as I want. And if I do this, if I do db.fruit, I have to mention the collection, .find, and then .pretty. And prettifying it makes it look like this, as opposed to one line. So I use pretty a lot, right? It's much nicer. And I see two. And notice in the first example, I've got brown bananas with the color of brown. And in the second example, I have an apple that's red, right, with the color, with a type, which I didn't have in the first one. So I have two documents inside my collection. Both of them have different properties, right? Different numbers of properties. In the first case, I have only 2 properties. In the second case, I have 3, not including the ID. So let's go back to this. So a little bit of syntax. So here in this particular case, I'm searching for comments count that are that are greater than 10, right? That's how I can find stuff, right? And again, $GT is greater than a certain number. And if I want to find, okay, so let's go back in that protracted example here. So I'm going to kind of do a CLS. So I'm using the fruits or the fruit collection, right? So I want to do another insert, db.fruit.insert. I want to insert another one where my name of my fruit is going to be tomato, right? Tomato is a fruit. You think it's not, but actually it is. And then it is because it's got seeds, right? So it's name tomato, and then color is also red, right? Color is red. And then, you know, the type, input type for this one as well is hothouse. Hothouse tomatoes, right? There's also tomatoes on the vine, and blah, 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 right? All right, press enter, and then we do that. We've inserted one. Now if I do a db.fruit.find.pretty, right? Then I can see 3 records or 3 documents, right? And then there's name apple, there's name, you know, thing. But I want to search for only ones that have a color of red, right? So I can do that. I can say db.find, db.fruit in the fruit collection, .find. And again, from my criteria perspective, take a look at this thing, find what I'm looking for, right? I can specify. The other time I just left it empty. If I leave it empty, I find everything. But if I'm searching for something else, I can read a specific thing. For example, where my color, right, is red. Only you know, fruits where my color is red. And then if I pump it into pretty, sorry, I forgot to do that. And I can only return 2 records. So filtering is really easy, right? All you got to do is pass in a value to find whatever you're finding, right? And you can pass in multiple values and it'll match them all. So if you have multiple, it'll just add them all up, right? And as long as it matches those values, where both this and that are true, then it'll return them. There's some really good examples here in the PowerPoints where it talks about how the index works. One of the things that it also talks about is replication and redundancy. And MongoDB kind of gives you this replication and redundancy built in off the top. Okay, so you have something called a primary, right? And then you have secondaries. And what happens is the primary instance, here's the primary instance, reads and writes. If the primary fails for whatever reason, one of the secondaries gets promoted. And the way this works is you have something else called an arbiter. This is the way it works. I'm just talking backend now, so you understand safety. One of the challenges people have is, oh my God, it's a single document database. What about the redundancy? How does it work? It works like this. So you have an arbiter, and the arbiter decides which of these secondaries becomes the primary if the primary fails. The primary shifts to the secondary, and when it comes back online, right? If it does come back online, it becomes a secondary. If it doesn't come back online, it's discarded, and a new secondary is created, right? From a replication perspective. So replication always happens inside of and we call this a replica set, right? For Mongo. So it's kind of neat. And they have also, of course, they use automatic failover, right? So again, it rejoins, like I said, as a secondary instance. The arbiter basically is the thing that elects a new primary. That's what it does, and it exists, right? So here's the example. When we talk about heartbeat means it's the arbiter is always connecting with the secondary and the primary to make sure that there's a connection between the two, that they exist. And if the primary doesn't exist or can't respond, or it takes too long for it to respond, primary instance of the database, then what happens is this is demoted and the secondary is promoted automatically. So the secondary always comes into play. Automatic switching as a backup. Very simple. From a scaling perspective, sometimes what happens is there's 2 types of scaling: vertical scaling like this, and horizontal scaling like this. And this is also true for all other databases, right? So horizontal scaling means that I want to increase the power of my database. I want to make it a super database with superpowers, more memory and more hard drive space, maybe SSDs and other things, right? That is completely illogical, right? And really resource expensive, right? Because for me to set up my database to really expand in power, and especially if I have only one instance, like one server. So we talked about, when I talked about this idea of automatically creating a replica set, what happens if the whole box dies? Like we're talking, the whole server dies. You need to have some kind of backup and redundancy. And there's two ways of doing it: vertical scaling and horizontal scaling. Vertical scaling means only one machine, big and powerful, and actually it's actually there's a weakness there. And then the other way that's more preferred is horizontal scaling, where you have multiple machines, right, that take care of each of these machines share the load. But there's a problem with this one. What's the problem here in terms of speed? Well, overhead, right? You have to you have a bit of overhead in terms of which machine is the current instance. So some issues, but this is how it's done usually. And by the way, it works the same in SQL databases as well. It's not just for this MongoDB stuff. And it kind of talks about that here in your PowerPoints. So again, the idea with different machines, whenever you hear the word sharding, the machines themselves in a horizontal scenario, like we talked about up here, these machines here are just called shards. That's just the verbiage, if you will, the words we use to describe the machines. So sharding is the process of creating separate machines to support the database. And we have a router in order for you to do that. Okay, so I'm not going to talk too much about this, but there's a bunch of new features that are built into MongoDB, and I think it's important for you, if you wanted to, if you're interested, you could read in terms of how it works and why you would use MongoDB as opposed to some other databases. By the way, other NoSQL databases have a lot of the same features nowadays. It's not just Mongo that has all that stuff, especially Firebase. Again, Firebase is a product of Google Labs, and I recommend you take a look at that. We will later anyway. Mongo Shell is what we talked about now, and I've kind of gone over it with you. The default database is the test database. That's why it came up first. Notice that it did that. So if I kind of quit, right, and if I clear, and if I go Mongo, then you can see that test connected to test comes up, because that's the test database that comes up first, right? In order for us to DBS, yeah. In order for us to connect to the other ones, right, we need to use the use command, right? So I would say use games. When I do that, I'm switched to the games database. So if I clear, use games, I'm switched to the games database. I can do that over and over again. It's not going to hurt anything if I keep doing that. It's just going to keep switching to the games database, right? That's one thing. In this case, they're using something called mean, doesn't exist. And you can also do this. So when you start off, and if you want to start with a specific database, you can go Mongo and then the database you want to use. So an example of that would be Mongo, and then instead of use games, I can say games. You can see that I'm connected to the games database. And if I do a db.game.find, because I made a game collection, then I can see that one game that I have in with the rating of 5, but we don't know the name of the title, right? We'll get back to this. Show DBS shows everything. We did our first insert. We did this, and what it does is it inserts something into the database. db.find finds all. That's what this does, right? You can show collections. If you want to drop a collection, you can use the keyword drop, right? So they'll delete the collection. Let's do that. So we're going to go back in here, and we're going to say db.game.drop. And then it's true. It will return with true. It means that there's no more collections. If I go show collections, I'm going to have nothing. Now let's create the collection. db.insert. Sorry, the collection name game.insert. And then what am I inserting again? I'm going to insert the name of the game. Right. So we'll say Fallout 4. And then the rating, which we gave it a 4.5. Let's just say. And let's even put a cost to it. Right, so cost, and then the value of the game, which is, and again, you can use quotations, or you actually can use, because it's JSON of actual value. But for now, I'm going to say $59.99. Probably not like that, but I'm just guessing. Press enter, and then if I do a db game.show or .find, sorry, db.game Yeah, fine. Oh, did it insert? Oh yeah. La 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 la. Boop boop. Oh, that too. Well, dude, thank you for that. So you guys know more about this than I do already. Isn't that interesting? My point is, it's intuitive. That's why I'm saying that, right? If you mess up, you can fix it easy. And you notice how I can just go up a step with my arrow keys and put in my thing. It's nice and easy, right? So I say db.game.find. You can see that there's all this. And again, db.game.find pretty, right? Means it's pretty. It's going to return it in this format, which is a nice way to see it. All right. So we got these things. All right, so we dropped it, and now we're going to be talking about CRUD operations, which is create, read, update, and delete. Those are the things we're going to do. And inside, we've done an insert already. There's also an update and a save. We're going to talk about what those things do. They're a little different. So insert, here's the insert. We've already done this piece into a particular collection, right? And here's an example of an update. Now notice that I talked about before. The update, there's two parts, right? One part is what you're searching for. I'm searching for user Alice in this case. The title is second post. The user is Alice again. Put it back, right? And then there's another part. So there's three parts to this update. One part, the first object that you're looking for is what you're searching for. The second object is what you're inserting or updating. And the third object is this object called upsert, right? And when you use the keyword upsert, if no document exists, it'll create one. That's what it does. Okay. So if there's no, you can't find Alice, insert her. That's what it means. Make sure she's added to the database. Save does something different, right? So when you call save, right? If, you know, again, if the document that doesn't exist have an ID field or has an ID field that doesn't exist in the collection, you can just do this. Right? And this will have the same effect as update, but we'll create a new document instead of updating an existing one. Right? That's a totally different thing altogether. So we use update a lot. We don't use save. Right? But again, like I said, I have the whole, usually what I have is the whole object that I'm updating. Right? So here's a good example of this. So I'm here, and I want to update the game from rating of 4.5, and my cost instead of $69.95 is $65.99. Right? As an example. How do I do that? Well, I would do this to be sure. So game update. What game am I looking for? I got to search for some kind of criteria. So the first part is an object that I'm looking for with a name that matches Fallout 4. Has to match exactly, right? And you can use matching regular expressions to match as well, right? Contains Fallout 4. If you want, with a name that contains Fallout 4, you can do that. And then comma, and then what you're going to update. It means you have to add the entire document back in, right? Basically, again, so I'm going to say where name, if you want to do it right, name is Fallout 4. And my rating now is going to move from 4.5 to 5. And then my cost is also going to change to $65.99. I made it more expensive. I was wrong, right? And then like this. If I did everything correctly, and if, by the way, I can use the last part, I can use upsert, right? You can use upsert. If I'm not wrong, it's got to be put in these kind of, oh no, it doesn't have to be. It can be just upsert like this, where it's true. So if it doesn't exist, it's going to create a document like this. Press enter. Notice it says match 1, upserted 0. So it didn't create one, modified 1, right? And then, yes, which is really powerful, right? So again, if I go db.game.find.pretty, and I see this. So you can see it's updated to 5, and say, but I had to put it all back. And again, I want you to think about that when it comes to code, you're putting a whole object back. You're creating an object and then putting it all back again. Yeah. It won't create it. If it doesn't find it, it won't create it. That's what happens. Okay. So that's creating and a little bit of reading. Right. Here's reading, we did this already, but you can actually be really good, find, and this one will do the same thing, right? So this finds all the documents, right? When you don't think, if you look for a specific document, you can specify what you're looking for. The field of the property of the document that you're looking at, I can't use field, the property of the document you're looking for. And here's an example of something else, right? So for example, retrieving all the posts that were created by either Alice or Bob, right? So where my user is either, when you use in, that's the either or, right? Alice, comma, Bob, you're creating an array of either one of these two users to return. If I had two different ones, right? So where the name is either Fallout or something else, as an example, if that makes sense. Okay. You can do, for example, my user Alice and my count, and when you put both two things, that's an automatic and my comment count is greater than 10, right? So how would that work? Comment count greater than 10. Well, imagine if we had another game, right? So we make another game. So we'll say db.game.insert, and we're inserting a new game with a name of Dark Souls 3 as an example, and a rating, keeping the same schema. We're purposely keeping the same schema. I don't have to keep the schema, but I'm doing it anyway, right? With a rating of 5, right? As an example, rating of 5, and a cost, right? Cost of $79.99. So bigger cost. And then we're closing this document off and pressing enter. We got another result we're done. If I do db.game.find, and I'm looking for, what I'm looking to find. I'm looking to find something with a cost, right? Here's I might look at my cost. So put it like this, where the cost is, and in brackets again, just two curly braces, right? $sign greater than, right? And then the value that you're looking for, right? $79.99. Be careful because it's something else, right? It's a string, not a value. Will it do it? So this is inside here, right? And this is inside here, and this is inside there, and then press enter. It doesn't find anything, right? Because my cost, right, is not a value. My cost is a string, right? So therefore, it does have variable. It has data types, right? True, a number you can put in, all that kind of stuff. Yeah, all the JSON data types are there, right? But if I did something like find it on cost, something that has a cost, right? I'm looking for an object that has a cost, right? That's not good. You can't just search in the cost. You have to search for a type of cost where the cost is equal to $79.99, right? If that's the case, if that's what you're looking for, then you're going to return 1, right? So that's something to note, that, because cost is a string here, you can't use the greater than, because the greater than only searches for values. Okay, so that's that stuff. And again, here's an example of I use an or. So find either user Alice or user Bob, one of the two with the or, right? Very simple syntax. Updating, we already did this. There's 3 arguments to updating, right? The first argument is selection, the second argument is the update, and the third argument is options. And here's an example of that. Okay, here's something. It says, for instance, in the following example, the first argument is telling Mongo to look for documents created by Alice, right? And then the second argument tells it to update the title field to the third argument. Now, this is interesting. What we did was we just said, change one argument. Change it, right? But here, if we use the set keyword, we only need to update 1, right? So let me show you that. So I want to update the rating of my Dark Souls 3 game from 5 to 4.9, right? So I do that. So I do db.game.update. I'm searching for the name, right? which is, I got to put it in as an object. So the object has to be in there. So name, which equal to Dark Souls 3, right? That's the first criteria. And then the second object that I'm looking for is what I'm going to replace. I can use the set, right? I want to set, and in curly braces, the rating, right, to 4.9. And then if I want anything else, I can put another object in here. And if I close this off, if I did this correctly, I didn't, right? So I did this. Oh, sorry, I know what I did wrong. It has to be an embedded document. This has to be embedded inside of a document like this. Yes. Because this request, because I'm using a special keyword, it has to be inside of the document request itself. And of course, that didn't work. Oh, because I don't have a. What was that? Yes, most likely. There we go. So now it's a modified one. Let's take a look at that. So if I go cls db.game.find, I want to find all. I did it, right? And it didn't take away the name like it did last time when I did the update. Last time I sent the whole object and I said, well, modify the whole object. This way I'm only setting one property of the object. So there's ways of doing that too. Now the multi one, this tells it, normally it does only one field, but if you want to multiply, if you want to use multiple or modify multiple documents, you have to use the multi option as true. Okay, so that's what it does. More or less, you've seen how you can save. Save is the same thing, where you can actually save a new object ID, right? It's very similar to update. And if it doesn't exist, it'll automatically create one. You don't have to use upsert as an example if it doesn't have one, right? Deleting, very similar. We use the remove. Takes two arguments: what you're deleting, find something to delete, and the second argument, whether or not to remove multiple documents. Right, so here's a remove. That means remove all. That would be bad. Don't do this, right? And this one would be just remove user Alice, right? So that's your delete. And then remove multiple documents with username of Alice. So maybe I have a username of Alice, then I have multiple things attached to Alice. We'll remove them all, right? But only Alice. Don't remove Bob, as an example, right? Guys, that's all. It really is all about MongoDB command line, if you will, right? Yeah. Yes. Yeah, because you're defining a property, right? And the property is case sensitive because just like JSON would be case sensitive, right? The only thing that always messes people up is just how you see how I had a problem with the curly braces, because you're passing objects, right? And each of the arguments is an object you're passing in, right, into that argument. Okay, before we go, and before I go on, I mean, yes.
Oh, when you're saying db.post, is that the post database
Post collection.
Or the post collection?
DB, remember that you have to use a certain database.
Right.
Once I'm in that database, I'm in that database.
Okay.
Now I'm using the post collection, right? Okay, let's go back. So I'm in here, right? Remember, I've been using pretty. So I'm db.find.pretty. This is good. Makes it easier for us to see this. Here's the thing I want to do now. I want to, one more thing that I want to do here is I want to embed an array, right? So for example, I want to have an array of different players, let's say, right? So my Fallout 4 game, I want to insert, right, an object, right? Or, that has a bunch of players, and there's going to be two players, right? Aaron and let's say Kevin, right? When I put Kevin in the game, Aaron's also in the game, right? There's going to be two people in there. How do I do that, right? In Fallout 4 or Dark Souls 3 or some other game, like maybe we'll call it. We won't use those two examples because it doesn't make any sense. We'll use Overwatch, right? There's a game that two people can play. So how do I do this? So again, I'm going to go db.insert. So I'm inserting a new game, right? And into my game collection. And again, I have to mention the name of the game, right? So name of the game is Overwatch, right? And then again, I got to put this inside of a. It doesn't take it without a a curly brace, because the curly brace, and sometimes to form it out, probably best to do it this way. Curly brace first. Inside the my Overwatch game, I want to change my rating. Well, rating is pretty good. You know, the rating is, let's say, we'll say 4.2. I'm making it up. And now let's say I want to have another document. How do I insert an array inside of a JSON document? Do I need another curly brace?
Yes.
Do I need a name for the array?
Yeah.
I need a name for the array. So what's the name for array? So players. Here's my players. And my players is an array, right? So I'm going to make it like an array. So square brackets, right? Let's try this out. And inside my square brackets, I have two names, right? I'll have Aaron, because maybe I only have values, like a string array, right? You can do this too, right? And Kevin. Will this work? Well, let's press enter and see what happens, right? So db.game.find, and then .pretty. I've got two things, and I've got a players with a players array with two players that I mentioned, Aaron and Kevin. Guess what? I don't have to accept player Aaron and Kevin. I can make each of these elements other documents. So player documents with name and with, you know, other stats about you. Name, age, contact number, email address, you know, whatever, kill ratio, right? I can put all that stuff inside there, because that will be other documents. And so I can store documents within documents this way. I could also do it like this, right? So I got players. Notice that these two don't have players, but it's all acceptable, right? I can store anything I want inside of my, and I didn't notice this one doesn't have a cost, right? I didn't include a cost, right? Each of them have a different ID, right? They're all different, and which is good. That keeps them separate. Clear? So I can do a lot of stuff like that. And we may have to do that in the future, where you have one object instead of another object instead of another object, because you're layering, you know, that's how, there is no relationships, right? We create the relationships. I'm making almost like another players table. And the players table or collection is inside of this, each of the objects specifically. So I could do it and say curly braces, players is actually an object, and the object itself has these, you know, these different things, right? Okay, so enough about Mongo syntax. Now, how do I connect to Mongo? Now, this is kind of connecting. I'm kind of encroaching on next week's lesson a little bit, but I have to, because if we don't encroach on next week's lesson, then remember we just talked about recreating our Express database and all that stuff, right? And how do I connect to Mongo? We need a module called Mongoose, right? So mongoosejs.com, I believe is where it is. There it is. mongoosejs.com. I'm going to copy that and put it on our Slack channel. So in general, second person, there you go. Right. This is our Mongoose. It's a Mongoose npm module. That's what this is. Right. So Mongoose basically gives us a couple things we need to do. One is we need to add Mongoose as a variable inside of our app.js. Okay. In order for us to do that, we need to do an npm install. Yeah. So let's do that now. Let's go to our project. I'm going to quit here for a second. Quit. I'm going to clear the screen. And what I want to do here is I want to include, when it's not my Mongo database, well, I won't actually, I'll leave it go because we'll come back to this. I want to npm install. Remember we did this last time. npm is no package manager. Hey, get Mongoose for me. So I want to use this new package because Mongoose is the middleware that I'm going to use to connect to my Mongo database. I need some way of connecting to it because Express does not have it built in. Neither does Node. We need to add that functionality in, the ability for us to connect to the database and do operations on the database, right? So npm install Mongoose. -- save because we want to use that as a one of our dependencies, our project dependencies. Whenever we use -- save. If I said -- save -dev, that would be a development dependency, not a project development dependency. And we can talk about development dependencies later, but really what you have to think about them is it's not critical for the project to run, but we need it because we're using it for testing, or we use it because we use some kind of things like TypeScript to help us do code hinting. That's not a project dependency, it's a development dependency to help us develop, right? So this is a project dependency because Mongoose are required, right? So we do that. We get Mongoose. Now it's going to be put inside the node modules folder, Mongoose, and all of its submodules, all of its dependencies, right? That's the first step. And then inside of our app.js, we're going to go back to app.js now. Notice on the top, we require express, we require the path, we require all this stuff. Well, somewhere in here, before we require our roots, here's our roots. Before we require our roots, we have to require Mongoose. So we're just going to put it in here. So this is where we're adding the Mongoose module. We'll do this again next week. I want to show you this so you understand how it works. Let Mongoose equal to require, right, Mongoose. Right now we can do this. We're actually requiring Mongoose inside of our project. We've got a Mongoose object, right? Mongoose is just the module. That's what the name is called. Okay. Now, this is interesting. We're defining and this is the simplest example, the connection. What's the connection string? If you are connecting locally, right, all you need to do is use MongoDB as the type of connection, localhost, and the database you're connecting to. What's our database called? Games, right? So this is what you need to do. So let's do that next. So we'll say Mongoose. So connect Mongoose database. Sorry, to the MongoDB. How about connect to MongoDB, right? And use the games database, right? That's what we're using in this example, right? So how do I do that? Mongoose.connect. Look how it comes up. This is why I use Visual Studio Code, right? And what do I need? A URI string where I say MongoDB, right? And then if you look at what it says, / localhost. You don't have to specify a port, right? Localhost, and the name of your database, which is games. That's the first part. Next, connection options. Next, a callback, right? That's the other option. Notice that it says connection options is the second one, and callback is the third, right? Where we have two things. We get an error. What if you get an error, right? And if you don't get an error, right? Notice this is what it returns. The callback returns an error. That's what it does here, right? Now there's a couple of them, right? Or a callback with a Mongo error, which returns void. And then notice what it says is type of Mongoose and then some kind of thing where if it doesn't return error, if it's not an error, then we know we've connected. Okay. How do I code that? And this is just by hand. So I go do one of these. Oh, no, it's like this, right? We take in an error, right? Where the error is a fat arrow function that returns this, right? And I can check if my error is true, then what do I want to do is I want to console log, right? Error connecting to the database, right? That's what I want to do. If it's an error, error connecting to the database, right? If it's not an error, then console log connected to MongoDB. Right? I'm making this up. I'm looking at my code hinting to help me. All right, let's try it out. So notice that my server's not running right now. So I'm going to run it with NodeMon. And if I do, connect it to MongoDB. I didn't have an error, right? I didn't have an error. So now I'm connected to MongoDB. Right? This is a key, right, to understand. So this part here, and I'm putting it all in my app.js. And we're not going to do that. We're going to actually refer to this next week in another document. But we've connected to the database. This is the first part. That's how you connect to the database. Let's go back to the online documentation for a second. All right, cool. And it actually shows us this, right? So kitty.save, and you can do something like this if you want to save. Now I want to be able to read from the database, right? here we created a mongoose model, right? Mongoose model called cat, right? That's the cat model. And here in the mongoose model, it defines two things. The one thing for the cat. The cat has a name, which is a type string, right? And then what I'm doing is I'm creating a new object of type cat where I'm passing in the name of the cat, right? That's what this is doing. And then I'm saving the name, right, which is like an insert. And I'm checking to see if there's an error. If there's an error, show me the error. If not, you know, console.log meow, I've added the cat in. And it's in the database. This is how I can add a cat into the database. But how can I read a cat from the database, right? Well, the great thing is all the documentation are right here, right? So if you want to look at some common things, here's how you define your schema. And you want to define your schema, this would be somewhere inside of another file. You wouldn't want to put this schema inside of your app.js. That doesn't make any sense, right? So we're going to see that next week, we're going to use a separate file for this, right, to include. How do I do this? Well, here's what we're going to do. Var mongoose, you require mongoose inside that file again, right? You're going to create a schema, right, which is of type mongoose schema. And inside the schema, you're going to define whatever the schema is called. In this case, we're going to have a schema called the game schema, right? Which is a new schema. It's a new object. And this is the schema is just creating a class. That's what it's equivalent to. And I'm defining strings, my title, my author, my body, my comments, which is actually, if you notice, an array, right? An array of body and date, an array of objects that include body and date, a date, which with a type of date, and a default value with a date now, right? That's what we can do it. And then here, hidden with Boolean, is it hidden or shown, right? And some meta where we have votes and favorites. This is a great example of a schema, right? Now this would be inside of a file, and what we'd want to probably do is we'd want to probably export this model out from here so we can use it. So if I go back to the original example in the front page, right, which is this example, here I'm defining a model, but I'm doing it in here. And then what I'm doing is I'm creating a new object of type cat. Model is cat. I'm creating a new object and I'm saving it, right? If I go back to, this is just schemas and models, and if I can do queries, how does queries work? Well, look, if I have a person model, here's an example, I want to find one. It's very close to the BSON that we saw earlier. Instead of find one, where I'm searching in the first name, right? Where the name.last is equal to ghost, and the name occupation, and whenever I put comma, the name occupation is, I want to be able to do that too. And then if I have an error, right, return the error. Otherwise, return the person. Person is the actual object that I'm returning, right? And if my error is true, handle the error. Otherwise, get the person.name.first, because person is the new object that I'm going to get back, right? And person.name.last and person.occupation. All those kinds of things. So very, very simple syntax. And if you know MongoDB, they kind of know how to do this. You can probably figure it out. Okay. And they give more protracted examples about how to do this. Person.find. So I'm looking inside the person collection, right? And then this is how it is. Well, if I was going to define a schema, right? And if we thought about this nicely, right? I'm defining a schema. I'd want to have it somewhere where I can get it, right? So I want to talk about Mongoose or games or something, right? And we're going to look at that next week, right? How do I define? Where do I define it? It's definitely not going to become in the. If I look at my folder structure, I'm just going to close some of these for now, right? Here it is. Okay, here's my folder structure as an example, right? It wouldn't be in my app.js. My app.js to have all this information makes no sense. It wouldn't come in here, right? What you want to do is you want to have another folder, right? It wouldn't be in your public folders. So it's going to be some other folder. And a lot of times we usually call it config. In my config folder, I want to kind of get information about Mongoose. So how do I do that? I would export from my config folder the URI of Mongoose and then connect to it. Right? I wouldn't want to hold it right here in my API. We're going to see that as another option. Does anyone understand what I've done here? How I've connected to MongoDB, right? This is the key. Now, question: if I put this up to Azure, I'm putting it up to Azure. Is it going to work? Why? The database is only local, right? Azure's not going to know where to go, and neither is Heroku. Heroku doesn't know, Azure doesn't know. So what I need to do is create another database that's online, right, for Azure and Heroku to work. Now this, I'm getting ahead of myself. I'm going to cover this next week again. Don't worry, right? But I want you to think about this, as you start building out your idea for what you're going to do for your final project, because your final project is going to use some kind of data store. My recommendation is you sign up with, if you haven't done it already, MLab, right? So here's MLab, which is Mongo Lab. It says you get 500 megs for free. Let's log in. Let's see if I can remember my login and username. Usually I don't. Usually I don't. Just saying, right? Now see invalid username or password pair. Let me see. Maybe it's something else. And the other thing is sometimes it only looks for just my first name, my last name. There we go. So yeah, save. So here's an example of some databases I already have, right? And I want to make a new database, right? So I'm going to create a new one. So first of all, create your plan, please. If you want to follow me, if you create your plan, are you logged in? All right, if you're logged in and if you created your plan on MLab, MLab is an online MongoDB database, right? So I'm going to click create. Notice my username is as an object. Take a look over here. My user is Theopolis and my account is me too, right? It's funny. Create new. So here's my new deployment. Now look what it says. It says, what's your cloud provider? Is it Amazon? Is it Google? Is it Microsoft? We'll leave Microsoft and we'll say, notice now we choose where it's going to be. So Amazon's US East, right? I'm going to choose Microsoft. I can choose Canada, Canada East, right? This is in Quebec City. Or it also is Canada Central, which is in Toronto. Let's say Toronto. If you're using, it'll work. So we're choosing where it's going to be, right? This just basically tells us, as an example, what the distance is and the latency, what server you want to use if you're doing that. Like maybe if you're planning out, I used Canada East, I think. So I'm going to just leave it as Canada East, right? Usually you want to try and match it up. My replica set cluster, if I choose to have a replica set, it'll cost me $200 a month, right? I don't want that. I want no replication, right? If I don't choose this, right? So my deployment, I'm not choosing one of these. These plans are suited for production environments demanding availability. I want to choose none of these, right? I need to create a replica of my database name. We're going to make it called games, right? Hold on. Yes? MongoDB, you can't access the local. Well, shared cluster, $15 per gigabyte. Different storage options here, right? We don't want any of these, right? We want none of these storage options. We want free, right? Or we don't have any kind of replica set at all. Single node is what you want to choose, right? Single node sandbox. So I've chosen, and again, you see how that works with Microsoft? I can just choose, if I chose Toronto, I don't have that single node sandbox. But if I choose the default, so if I go back to Amazon, and then I go to Microsoft, I click single node. Notice I can't choose anything but West, I think, or East. I think it's West US or East US. Single node is what I want. Free. Free. Don't choose anything that costs any money. Right? And then it says Mongo version 3.2x. Who cares? Notice the price is going to be $0 per month. My database name is going to be games. And then create new Mongo deployment. It's going to do it. And I'm done. All right, so I got my games database. There it is, games database. And if I click into it, you're going to see the connection string. Take a look. To connect using the Mongo shell, to connect using a driver via the standard MongoDB URI, you need a username and password. What's my username and password? You can create one. Here's your users, right? Notice there's no users in this. And notice here's the collections. We can create all the collections and the details right here. So I can create all my data up here on MLab, and then I can read it. And we're going to use MLab extensively in this course, so please sign up if you haven't done it already. So now let me make a user really quickly. So here's my users. Add a database user. I'm going to make one. I'm going to call him Thomas, and my database password 12345 for you guys to test with. And then create. So here's my database password. It's not read only. My database user, I mean. Right, here's my. I don't want to click this. If I click this, he'll be deleted. Right. So I got my user, and if I look at my username, it's got to be this format: MongoDB user password :password at, and this thing. So let's do that. I'm gonna kind of grab this. Yours will be different, right? So copy. I'm gonna go back to my this part here. This is why it shouldn't be here in my app.js. It should be somewhere else. In my configuration somewhere. Right? So here where I have this URI right here, we can use a URI variable, right? So we can say something like this. We're going to fix this up later on. URI, or Mongoose URI, which is let URI, capital letters, equals to, and then we'll put that in there, right? Where my DB user is equal to me. And my password is equal to 12345, like I said, right? That's my URI. And instead of putting this right here as a hard-coded value, I'll just use URI. So I can do that, right? Now it's going to connect. Now, this is the great test. If I save it, if I go back here, and if it connected, right, then everything's great. Did it connect? Do I get an error? What's happening? No.
Oh, yeah, it takes a while.
Here's my server starting, right? And not getting a connection. Now, there's a reason for this, right? When you're connecting to MLab, right? I'm using this error output situation, right? Which is okay, but it takes a long time to connect. Long time this way. If this takes this long, something's wrong, right? Usually it doesn't take that long. Oop, error connecting to the database, see? So what did I do wrong? There's only two possibilities. One, my username and password combination is wrong. So it's my user, Thomas, password, whatever. Here's my MLab, right? What could it be? Right. MongoDB is the same, right? And let's take a look, make sure that my URI is formed correctly, right? MongoDB, Thomas 12345 at games, right? How about brackets? You think I need those? That tells me something else. That username and password like this, that says put your username and password in here. That's what this means. I actually get an immediate error, right? So if I go back to here, it shouldn't allow me to restart. You notice that it shouldn't take this long. It should be instant, right? To test this, if you really want to test out how connect the database first, and then I'll leave you with this talk because we're almost done for the day. Let me stop the server, right? And I'll clear the screen. And remember, we can also connect to the database like this, right? For my username and password. So I'll take the string, this string here, copy it, go to my command line, paste it, right? And then I'm going to go back and change the username and password. For my password is, my username is Thomas, and my password is password. 12345, right? Curious, will this work? Connecting to Now, here's the error that I'm getting. Failed to connect after this much seconds. Couldn't connect to server. Attempt failed. Why do you think this is? Yes. Here at the school, port 27017 ain't working. I bet you if I went to, and I'll try this on when I stop. I bet you if I go and connect to my little machine, right? My little hotspot, it'll work just fine. Because look, it says exception, connect failed. All right? It's trying to connect just to this part. Never mind to this to authenticate me, right? And then it's trying, couldn't connect to server, and I'm getting an error. So I want you to keep that in mind. And when you're working from home, it might work great. But working from the school, especially since I'm wired in, I may not work, right? Which means it causes a bit of a, in our mind, should we or shouldn't we? Now, will this cause me to stop with Azure or Heroku if I upload it to Heroku or Azure?
No.
Well, the server will go on, right? Just I won't have my connection to the database if something goes wrong, right? But I can't tell because I'm not really doing anything with the database, right? I'm not retrieving any data, right? So that's one of the challenges. So I want you to try this out yourself. I mean, remember what I've done here. I've tried to connect to the Mongo shell, right? And I'm using my username and password. If you think it's wrong, try putting in quotations in here as well. That's another thing that maybe how I've structured is wrong, where my username is Thomas. You might think this is the thing. My password is 123455, right? And press enter, right? And you're going to see that it has nothing to do with it. It didn't get there. It's trying to connect, and then it says connect failed, right? Couldn't connect to the server. That's what it says. It has nothing to do with my username and password. Guys and girls, that's it for this week. We'll continue with Mongo and MLab next week, right? I just wanted to show you how to connect it and modify it. I'm not going to put this up to Git this week because if I do, then it'll break my Azure and Heroku connection. I want you to have that. But next week, when we kind of come back, I'll show you how to connect. We'll do full CRUD next week as well. And all that stuff will be ready to go. Thank you so much and see you next week. Remember that next week on Friday, your assignment 1 is due. Please start tonight for that 2% bonus.